Welcome to Circuits Analytica. In this video, we will discuss structural style of modeling of a 4-channel multiplexer in Verilog HDL. In structural modeling, a device is modeled as an interconnection of available sub-circuits. The modeling of a circuit is identified as structural modeling by the presence of a gate instantiation or module instantiation. The syntax for module instantiation is as follows. Module name space instance name space open bracket list of ports or signals close bracket semicolon. Here module name is the name of the module which we want to use as a sub-circuit. For example, we want to realize a 4:1 multiplexer using 3 2:1 multiplexers. Suppose module name of the 2:1 multiplexer is D_mux2:1, which is specified in the Verilog code for the 2:1 multiplexer. We have to write that name, we have to use that name as the module name. Then instance name is the label given for that module for identification purpose. And then as the next step, inside bracket, we have to specify the ports or signals which are connected to the sub-circuit. So we are going to model a 4:1 multiplexer using 3 2:1 multiplexers. So let us start our discussion with the Verilog HDL code for a 2:1 multiplexer. On the right side of the screen, internal diagram of a 2:1 multiplexer is shown, and on the left side, the external view of the 2:1 multiplexer is shown. There are 4 ports. A, B and S are the input ports and Z is the output port for the 2:1 multiplexer. The name of the module is D_mux2:1. So in the internal diagram, we can see 3 signals or wires mentioned as N1, N2 and N3. N1 is the output of the NOT gate, while N2 and N3 are the outputs of the 2-input AND gates. This is the Verilog HDL code for a 2:1 multiplexer. Module space D_mux2:1 open bracket A, B, S, Z close bracket semicolon. This line specifies that the module is named as D_mux2:1 and the ports of this module are A, B, S and Z. Next line, output Z, specifies that Z is the output port, and the line input A, B, S semicolon mentions that the ports A, B and S are input ports. Next line, wire N1, N2, N3 declares 3 internal signals denoted as N1, N2 and N3. Next line is assign N1 is equal to not of S semicolon. The wire N1 is driven by the output of a NOT gate whose input is the select line S. Assign N2 is equal to B and S semicolon. Assign N3 is equal to A and N1 semicolon. specifies that the signal N3 is driven by the output of a two-input AND gate whose two inputs are A and N1. Finally, assign Z is equal to N1 or N2 mentions that the output port Z is driven by an OR gate whose two inputs are N1 and N2. Finally, the line end module specifies that we have completed the Verilog HDL program. So before writing the code for the 4:1 multiplexer, we have to write the code for 2:1 multiplexer. We must compile it to make sure that this is available in the Verilog environment as a component. Now let us realize a 4:1 multiplexer using three 2:1 multiplexers. On the left side of the screen, external view of the 4:1 multiplexer is shown. The module is named as S_MUX421. That letter S denotes that the style of modeling is structural modeling. The four channels are P, Q, R and T. The select lines are S1 and S0 and the output is defined as Y. On the right side of the screen we can see the internal diagram where three 2:1 multiplexers are used to implement the 4:1 multiplexer. The 2:1 multiplexers are labeled as M1, M2 and M3. Module name of the 2:1 multiplexer is D_MUX221. So now, let us write the Verilog HDL code for the 4:1 multiplexer. So for the 2:1 multiplexer, first port defined in the Verilog HDL code is A, then B, then S and Z. We have to maintain this order when we instantiate this as a component in the Verilog HDL code for the 4:1 multiplexer. This is the Verilog HDL code for a 4:1 multiplexer. Module S_MUX421 open bracket P, Q, R, T, S1, S0, Y specifies that the module is named as S_MUX421 with ports P, Q, R, T, S1, S0 and Y. The next line, output Y, mentions that Y is an output port. The line input P, Q, R, T, S1, S0 specifies that the ports P, Q, R, T, S1 and S0 are input ports. And there are two signals defined as N1 and N2. So wire N1, N2 defines two internal signals. Now following that we are going to do the component instantiation. Module name of the component which we are going to use is D_MUX221. M1 is the label for first multiplexer. The first port of the 2:1 multiplexer is A, which is connected to P. Second port of the 2:1 multiplexer is B, which is connected to Q. Third port of the 2:1 multiplexer is S, which is connected to S0. And finally, output is connected to signal N1. The next line D underscore mux221 space M2 open bracket R comma T comma S0 comma N2 close bracket semicolon specifies that the second 2:1 multiplexer is labeled as M2. Module name of the component which we have used here is D underscore mux221. Then inside bracket, first port of the 2:1 mux which we are using as a component is A. Input channel R is connected to A. Second port of the 2:1 multiplexer which we are using is B. Input channel T of the 4:1 multiplexer is connected to B input of the second 2:1 multiplexer. Third input of the 2:1 multiplexer is S. Select line S0 is connected to third input of the 2:1 multiplexer. And finally, output of the 2:1 multiplexer Z is connected to internal signal or wire N2, close bracket semicolon. Next line is D underscore mux221 space M3 open bracket dot A inside bracket N1 comma dot B inside bracket N2 comma dot S inside bracket S1 comma dot Z inside bracket Y close bracket, then closing the second bracket semicolon end module semicolon. So you compare the three instantiations. In the first two component instantiation, the type of association of the ports of the 2:1 multiplexer is positional association. Based on the position of the ports, we have connected the ports or signals of the circuit under consideration. While for the third component instantiation, D underscore mux221 space M3 open bracket dot A N1 comma dot B N2 comma dot S S1 comma dot Z Y close bracket semicolon. Here the type of association is named association. So there are two different ways to associate a sub-circuit with a circuit: named association and positional association. The first two instantiations, the instances M1 and M2, are the examples for positional association, while the third instance M3 is an example for named association. So the previous slide shows the Verilog HDL code for a 4-channel multiplexer using structural modeling. The 4-channel multiplexer is implemented using user-defined already available compiled component named as D underscore mux221. The first and second components M1 and M2 are instantiated using positional association, and the third instance of the 2:1 mux M3 is instantiated using named association. Thanks for watching Circuits Analytica. Enjoy learning.